in the body, we want to make sure that we maintain pH. So we have to be able to resist any changes in pH, right? And for the most part, what affects the pH are your hydronium concentrations and your hydroxide concentrations. So what are things that can affect the pH? Those two. So if we can create a solution that captures hydronium and hydroxides, then we can resist changes in pH. I like to say we can maintain our pH. So how do we maintain pH? We use a buffer. So a buffer solution maintains pH. Now, a lot of people get confused and they think a buffer means it's a neutral pH. The pH doesn't have to be neutral. It just has to stay the same. So you can have a buffered solution at a pH of 2.65. The thing is, when you add acid or base in small amounts, it stays at a pH of 2.65. It maintains that pH. That's what a buffer does. So they resist changes in pH when a small amount of acid or base are added. So how does it do that? Well, for example, your body can absorb small amounts, right? Because we have to maintain homeostasis and have the proper pH. Otherwise, our cell organelles would unfold and our cells would burst and die. So we have to maintain blood pH of between 7.2 and 7.4. So how can we do that? Well, if I took water and I added hydronium to it, the pH would drastically change from 7 to 4 because I'm adding a bunch of hydronium. If I add base, it would drop down, it would be very basic and it would go to 10.5. Buffers can maintain the pH. And again, it doesn't have to be 7. I want to make sure you know that. It doesn't have to be 7. It just has to maintain pH. So it won't change very much. So what are the components of a buffer and how does it do this? They're acid-base conjugate pairs. So to have a buffer, you need a weak acid and its conjugate base, and you typically have equal amounts of it. The other option is you could have a weak base and its conjugate acid. But again, you're going to have equal concentrations. So here's an example. I have a weak acid, acetic acid. How do I know it's weak? It's not one of the 6 strong. I have its conjugate base. How do I know that acetate's its conjugate base? Well, as an acid, if it donates a proton, what would be left? Just the acetate ion. So why is this important? If I add base to this solution, my acetic acid, my weak acid, which normally doesn't dissociate, it's a molecule, but it will donate its proton to the hydroxide. And what that'll do is it'll lower this and slightly raise this. But more importantly, that proton from the acetic acid will neutralize the hydroxide and make it water. So that's maintaining the pH. Now, if I add a bunch of acid to this buffer solution, what'll happen? Well, the acetate ion is the conjugate base to a weak acid. So the hydronium will protonate that. And what I'll get is, I'll get a decrease in this and an increase in this acetic acid, but that mainly doesn't dissociate because it's a weak acid. And what'll happen is the hydronium ion and the acetate will combine to give me water, right? So it'll give me water. And the water is the conjugate base to this acid, and it'll give me acetic acid. which is the conjugate acid to this base. So this is my acid because it's a proton donor. This is my base because it's a proton acceptor. And I get the conjugate acid, which is the weak acid found in this buffer solution. So this last slide kind of shows it, right? So what do I have? I basically have acetic acid, right? And its conjugate base. Now they write it as, they remove this and they write Na because that's how I get it dissolved in solution. I put sodium acetate in solution. The sodium dissociates because it's soluble, and now I have a bunch of acetate. So if I add acid, the acetate comes in, binds to it, and just forms acetic acid, which is weak and doesn't dissociate. It pretty much stays as a molecule. But if I add hydroxide base, the hydroxide will react with the acetic acid and break this bond to produce water and get neutralized. So that's essentially what buffers do. The weak acid, right? The weak acid is going to neutralize base that's added, and the conjugate base is going to neutralize acid when it's added. So when I look at this, can I identify if they are buffers or not? So how can I do that? That can't be a buffer. Why? HCl is a strong acid. Strong acids don't make buffers. Carbonic acid and sodium bicarbonate. Well, this is a weak acid, and that's its right? So this is a weak acid. Whoops. Oh, I guess it shows you right there. I'll just do it. And this is its conjugate base, sodium bicarbonate. So this is a buffer. This is not a buffer. Even though phosphoric acid is a weak acid, the chloride ion is not the conjugate base. The conjugate base to phosphoric acid, once it donates a proton, would be H2PO4-, which is dihydrogen phosphate. So because it doesn't have the salt or the conjugate base of the phosphate, this is not a buffer. And lastly, this is a buffer. Why? I have a weak acid and its salt or its conjugate base.